Indian.
All right, so we are going to do angles and degrees, okay? So, yes, we know about angles from geometry and everything like that, but they're going to start getting a little bit more in depth with them. They're going to start calling them more than just an angle with a vertex, okay? So go ahead and hit enter. All right, so yes, we have a vertex, all right? I don't like that they call this alpha here. I want you to get used to thinking of this as theta, okay? Okay, the reason is theta is just a fancy variable for the measure of a degree, okay? It's just a fancy variable. Kind of like in all of our algebra, x is what we usually go to, right? X is kind of our go-to variable when we're looking to solve for something, okay? Theta is like that fancy variable for the angle measure, okay? You have an initial side and you have a terminal side. And all that means is initial side is the side you're going to start at, okay? And the terminal side, what's terminal mean if you have a terminal illness? You're going to end there, okay? And this is where you're going to end, okay? That's going to be very important, okay? So when they're talking to you about this angle and they're talking about the terminal side, they're talking about where the angle ends at, okay? Vertex is still the same as we know it, okay? Okay, go ahead and hit enter. So the vertex will always be a fixed point. Go ahead and hit enter again, yeah. And again, okay, so that's basically what we just talked about. Okay, go ahead and hit enter. All right, so let's look at these. All right, rotation of the angle. So basically, it's like saying, you know, you have this open or closed mouth and then you're gonna open it. They consider that like the rotation, okay? And if I rotate all the way around 360 degrees, my hand won't do that. Okay, so the initial side starts here, okay? And then the terminal side ends at 120 degrees. Does everybody remember how we name our quadrants?
1, O plus plus.
What's this one? What quadrant is this one? 2. And this one?
What we're talking about.
3.
And this one?
4.
Okay, all right, so the initial side in this one can go the opposite direction, okay? So we've got counterclockwise is going to be positive, clockwise is going to be negative, okay? So if you look at our unit circle, it starts at 0, 90, 180, 270, and back to 360, okay? So kind of like the way you run a track when you go to the track to run. Okay, you're going to run that direction. The minute you go in the reverse opposite way, that's going to be negative. Okay, so initial side, terminal side. Standard position, okay? All of these are in standard position. Does anybody know what that means?
Martina to the office, please. Martina to the office, please.
Like standard form.
They're on the
Kind of.
origin.
There we go. They always start on the origin. The vertex is always on the origin. Where is the initial side always?
Plus plus 1. I don't know. X positive.
Positive x-axis. Okay, so initials or standard position means the vertex is at the origin and the initial side is on the positive x-axis, okay? So they're gonna refer to this in word problems and other different things that we're gonna do throughout this unit, okay? Go ahead and hit enter. All right, so let's look at this. All right, so the most common unit that we use is degrees, okay? But we can also use minutes and seconds, okay? So 1/60th of the measure of an angle of an equilateral triangle is equivalent to 1 unit or 1 degree, okay? And so on and so forth, so with minutes and seconds. Go ahead and hit enter, and I'll show you how we're gonna do this. So what we use this for is longitude and latitude. So some of you guys have been seeing the little activity that we've got. Once we do this, we'll do that activity. We'll try to get that done today. All right, go ahead and hit enter. All right, so if we look at this, I think it's just easiest to kind of jump in here. It says change north latitude 15.735 degrees to degrees, minutes, and seconds. Okay? So we're going to change this to degrees, minutes, and seconds. The way we do that is anything in front of the decimal is our degrees.
Isn't it already at degrees? Oh.
Yeah. So we have 15 degrees. Everything after the decimal
Is minutes?
is going to be minutes, but we have to do something to it. What did we say about it a while ago? We said that 1 degree was equivalent to what? 1/60th of a second, right?
So it's multiplied like 1/60th.
Do we multiply it by 1/60th? Does everybody agree?
If it was
No,
divided by
divided by
1/60th.
1/60th.
Okay, which would be the same as
Multiplying it by 60.
by multiplying it by 60. Good. So I'm going to take, to get the minutes, I'm going to take 0.735 times 60. And you'll have to tell me what you get.
44.1.
44.1. Okay? Again, everything in front of the decimal is our minutes. So 44 minutes. We're just gonna put the little hash mark. So when we talk about someone's height, we do, let's say they're 6'4". This is kind of gonna be the same thing with minutes and seconds. It's gonna go minutes and then seconds, okay? So we're gonna take that same thing that we did, that same process, and we're gonna take what's after the decimal point. Okay, so we're gonna take 0.1. And how do you think we're gonna get seconds?
Multiply it by 60.
Again, good. Multiply it by 60 again, and what do you get?
0.60.
Just 60. No, just 60. I did 0.1.
0.1 times 6.
Should just move the decimal
Yeah,
ones
you're
back.
right. You're right.
Okay, those are kind of close together. All right, so I have 15 degrees, 44 minutes, and 6 seconds, okay? So this is how they do like longitude and latitude. So on all those movies, like when you hear them telling like they're like, how many of you have seen what's Perfect Storm? When they're out there and they're trying to tell their location and on movies and you're like, what does all that mean? Well, this is what it means, okay? All right, so this time though, they want us to work it backwards. It says take 39 degrees, 5 minutes, and 34 seconds, and round it to the nearest thousands. It wants us to put this as a decimal. So 1 big long degrees, like what we just started with. Okay, so does 39 change at all?
No.
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 So I'm gonna have 39 plus, how do I change 5 minutes back?
Divided by
Multiply
60.
60.
Okay,
I could be wrong.
or which would be the same as
Divided by 60.
dividing by 60. So 5 divided by 60 is
0.08, 3 repeating.
point what?
0.08333333.
Okay, so let's just put 0.083 plus, how do I change 34 seconds?
Divided by 60.
Well, let's think about that.
Divide by 0.083.
No,
Okay.
you were close when you said 60. So let's think
Six.
about this. When I multiplied this one times 60, this had already been multiplied by 60, right?
Mm-hmm.
And then I multiplied it by 60 again.
Divided by
120.
120.
Close. We multiplied them by 60 2 times. So what's 60 times 60?
So divided by 360.
3,600.
Or 3,600.
Okay, so what do you get when you divide that by 3,600?
0.0094.
0.0094. Okay. All right, so we're gonna add all that together.
So
You should get 39 point.
plus 0094. 0.0924.
39.09.
Because this wasn't this 333 you said.
Yeah.
Okay, So is this what you guys got?
Yeah, I got
Now.
2-4.
I got 2, 4.
You got 2, 4?
Yes.
Well,
because, yeah.
we should have put a 3 here. If they ask me to round to the nearest thousands, which place is that?
The third.
Yes,
Yeah,
the third
2.
spot. So if I was gonna round that to the nearest thousands, would I run it rounded up or just stay the same?
Up.
Up. So it would actually be 39.093 degrees. Okay, so far so good? Okay, go ahead and hit enter. All right, so let's look at these. Okay, so we just talked about the quadrants, all right? And a quadrantal angle is one that lands exactly at one of the quadrants, okay? We said this starts at 0, this goes to 90, 180, 270, back to 360, okay? Anytime I have one of those angle measures, okay, with the exception of 0, okay, we have a quadrant angle, okay? Go ahead and hit enter. And a full rotation is what around here?
360.
360. Okay, so if I have 5.5 rotations clockwise, which way is clockwise?
Negative.
Negative,
The
good.
way clock
It's like
is.
1, 2, 3, 4, 5.
You're gonna need a bigger graph.
Okay? So that's kind of what it would look like, right? How can I figure out what that degrees would be?
Multiply it
By?
360.
Now he said it was gonna be,
Negative 360.
there we go.
Swirly.
So 5.5 times negative 360. What'd you get? Bullseye.
Negative 1980.
Good.
Negative 1980.
Does everybody understand why it's negative? Because once they say clockwise, okay, it goes down and around. All right, let's look at the next one. 3.3 rotations counterclockwise. So think about counterclockwise. We go
Positive.
1, 2, 3, and a third. It would be kind of around in there somewhere. Okay, so how would I get this one?
Multiply 360.
Good.
3.3.
Okay, what'd you guys get?
1,188.
1,188?
Yeah.
Okay, good. So far, so good? So a rotation is just a full circle. All right, go ahead and hit enter. Okay, so coterminal angles. If something is coexisting, what's that mean?
It basically balances off something else.
What if you cohabitate?
It
You
means
share.
other things.
You share. There we go, that's a good one. You're in the same space, right? Okay, so coterminal means, what's the terminal side?
The temperature.
Thermal maybe is temperature.
Dang it.
Okay, so coterminal means that I'm gonna have angles that end at the same exact spot. So meaning, it kind of looks like this. Let's say I start out with this angle, and it goes, and let's say it stops here. So it's in standard position, and it stopped here, okay? Well, I can have another angle that is called coterminal that goes and starts in standard position and only goes Did it go the same amount of rotations?
No.
No. I can even have another one that's coterminal that starts in standard position and goes, try not to mix my colors too bad. There. They start and they stop in the same place, but the amount of rotations is going to change. okay? So in this case, alpha, okay, that's what we said, it's kind of like any angle. They can give me any angle, okay? And I said it doesn't matter which direction, it doesn't matter how many rotations, it just matters that it ends in the same spot. So 360K, where K is just we pick how many rotations this thing is gonna make. All right, so go ahead and hit enter. All right, so let's look at this one. Actually, go back and I'm gonna write that real quick. I'm gonna write this. All right, go ahead and hit enter. Okay, identify all angles that are coterminal with each angle. Then find one positive angle and one negative angle that are coterminal. I think it's gonna be easier to do the second part first, okay? So, what this looks like is this. Sometimes it helps to visualize. Okay? I want one positive coterminal angle. Now, that is our formula, right? Theta plus 360K. I can pick K as anything I want. What's theta though?
Transient variable.
What is it in this problem?
45 degrees.
45 degrees, okay? So in order to find a coterminal angle, okay, I can go positive. So which direction do I need to go for this thing to be positive?
Counterclockwise.
Okay, good. So I could go this way, and I could land there. How many rotations did that take?
1.
1. K represents rotations. Okay, and I did one positive rotation, right? So 360K times that one positive rotation gives me what?
360.
405.
Good. No, what is it?
405.
Good. So there's my positive coterminal. Does that make sense? Which makes sense. If I go a whole rotation and then I go back up to 45, that's 360 plus 45. Now I need a negative one. Okay, so I can use that same thing. Okay, theta is still 45, right?
Yes.
Comes negative 1.
We could do a negative one. So now I have 45 minus 360. What's that equal?
Negative 60.
Put in your calculator.
Negative 315.
What? Say it again.
Negative 315.
Good. Negative 315. So did I do one positive and one negative coterminal? Yes, I did. All right. Now they want me to say the infinite possibilities. Okay? Doesn't this give me infinite possibilities?
Yes.
Okay, so let's write that. What did we say theta was?
45.
Okay, so if I take 45 degrees, which is my theta, and I add 360K,
Theta just doesn't ring.
where
Yeah.
K,
I think we should call it theta.
I think we should call it fatty.
where K has to be an integer. We said that earlier. K has to be an integer. That is the infinite amount of, I can pick anything from K.
Says
Okay.
got a fatty.
So which part of that would be the answer?
All of it.
You got a
So this
fatty.
one identifies
Yeah,
all
all right.
angles, okay, that are coterminal. This one right here, this is my positive angle, okay, and this one right here, this is my negative angle, coterminal,
Hey.
okay? All right, so let's do this next one. All right, so now that we kind of understand what's going on, how do I find the infinite amount for this one? What would I put?
Oh,
225 plus 360.
Good. What about K? What's important about K?
Two
K is an
rotations.
integer.
I don't know how many rotations I have.
Good. K is an element of the integers. All right. How would I find a positive one that's coterminal? What would I do to 225?
Add it to
Oh, you're going so
360.
quickly. Okay.
How did we find a positive one earlier?
Plug one in
Multiply
for K.
negative.
Positive one.
Multiply by a 1.
Okay.
A positive number.
Which is the same thing as adding 360.
Negative times
Okay.
positive. What?
Yeah. 1 times anything is just going to be 360, right?
Yeah, then times
Okay.
a positive number.
Times positive 1. So anything times 1 is still 360. So 360 plus 225 is. Everybody's asleep this morning. 585.
585.
Okay. How would I find the coterminal angle that is negative? 225.
Minus 360.
Good. So what do you get when you take 225 minus 360?
Negative 135.
Say it again.
Negative 135.
He had that number. He just knew it.
He was ready.
Also, it's kind of like essentially adding plates onto the weightlifting bar. I mean, we haven't hit anything besides 315.
Okay. So far, so good. Go ahead and hit enter.
I guess.
Okay.
Wait.
Go back.
No.
You
I
good?
just need a copy.
Okay.
of the-
Alright, so go ahead and hit enter. Was that the very last thing in this
Yeah, I
section?
think we're done.
Okay, so you're
Did you put
gonna
my grade
do.
in for my correction.
Oh, this is not.
Did you put my correction in?
No. Go ahead and hit enter again. Okay, so
Did
let's
you
look
put
at
my
this one.
correction in?
Alright, let's look at this one.
Change the subject mentions in.
I am filming, dude.
Filming?
Uh-huh.
Yeah, right there.
Okay, so let's look at this. Alright, what's it say? If each angle is in standard position, determine a coterminal angle that is
This is a shout out to all my friends.
Hey, Justin. Okay, let's look at this. Alright, so state the quadrant in each, okay, for the terminal side. Alright, so let's look at this. How would I figure out where this thing lies? One, if it starts at the initial, okay, standard position, specifically says, how do I get to 775?
You go around the thing.
Okay, that would be what?
Counterclockwise.
Uh-huh, how many degrees is that, rotation?
That's 360.
So if I subtract 360 from it, what do I get?
It would be like 2.5 times, or 2.25.
That'd be 415.
Okay, so that means I need to go another rotation, so I need to go another 360.
And then 55.
Okay, she says, and then 55.
Yeah.
Count sheet.
Okay, so is 55 gonna be in what angle, or what quadrant? Okay, so the quadrant of the terminal side is in quadrant 1, okay? And then it wants us to determine a coterminal angle that is between 0 and 360.
4. What? Cannot be.
Okay, so think about this.
1.
I need an angle
1?
Oh,
that
55.
starts
Starts there.
and stops
55.
and is, there we go, and is less than 360, 55 degrees. So basically, I just took away the
360.
extra rotations till I was left with something that was less than 360. Okay, let's do the next one.
We're done.
Let's do this one. We're done. We answered everything they asked us to do. All right, let's look at this one. Okay, standard position.
I don't have that one.
What do we know about negative? Which direction are we gonna go?
Clockwise.
Clockwise. So one rotation is, would I
360.
subtract 360 from this thing? Add. So what do I get when I add 360?
Negative 937.
Okay, so can I go again?
Yeah.
Okay, so we're gonna add another 360. What do you get?
-577.
So I can go again.
-217.
Okay, I got a question. Am I between 0 and 360?
No.
Why not? Agree.
Not positive.
Exactly. So I have to go one more time.
113.
Say it again.
113. Nope, that's so wrong. 143.
Are you sure?
I promise.
Okay. All right. So what quadrant is this going to land in? From here to here is 90. From here to here.
1,
So what quadrant does that land in?
3.
3. Okay. Now, what is the coterminal angle between 0 and 360?
143.
143. The coterminal angle is that one. And it goes around. Okay, so far so good?
Let's do method 2.
We're not gonna do
Angles
this. This is
throw
where we're
off
gonna
the
do this.
whole illusion.
Hit
What'd you
enter.
say?
Oh
What'd
my
you say?
lord.
Angles
Just
throw
ignore,
off the
ignore,
whole
ignore,
illusion.
ignore.
What kind of illusion?
Okay, let's look at this one. Alright, focus, Schubert. Okay, a reference angle. Alright, so the easiest way to think about a reference angle is you find the x-axis and you go the shortest distance from the terminal side, which means where the angle ends, back to the x-axis. So, terminal side is here. Here's the other one. Where's the closest x-axis? Here or here?
There.
The right side, okay? This is my reference angle. Okay, let's look at this next one, okay? What's a shorter distance? This distance or 2?
I can't
Negative
see this.
theta.
Okay? Okay, so this one right here would be our reference angle. Okay, let's look at this one. It ends here. Would this side, the left side, or the right side be the shortest distance?
Left.
That's my reference angle. Okay? What about here?
Right.
Right or left?
Right.
Right. All of those are going to be less than 1.
4.
Or
Oh, 136.
if it's
36. 336. 360.
all of these angles are less than what?
360.
90 degrees.
What?
If I just keep answering
The reference
right, I'll
angle is
never
less
be
than
wrong.
90 degrees. Okay, go ahead and hit enter. Let's talk about how we would find these. So let's look at 120. Standard position. This goes to 90. 120 is somewhere in here. This is 120 degrees. Okay, where's the closest distance? To the left, to the right?
To the left.
This is my reference angle. How do I find that angle measurement?
180 minus 120.
Good. 180 minus 120, which leaves me with
60.
60. So this reference angle is 60 degrees. This is the easiest way, I think, to do it. Trying to memorize those formulas, I think, is only going to mess you up.
Wait,
Okay?
let me write that down now.
Am I high on meters? We high on meters.
Okay, if it's negative, in standard position, which way does my thing go? Do I go up? Do I go down?
Clockwise.
Okay? 90, 135 is somewhere over here. It's 135 degrees.
180.
Where's the reference angle, on the left or the right?
The left.
So I need to find out what this is gonna be.
180 plus 180.
Okay, so she says I can take 180,
I'm kidding.
is it? Yeah, if it's negative 135. What do you get?
50.
45?
45.
45.
That's how I was saying.
4, 5.
Now, since this is going from here to here, does that mean my reference angle is negative?
Yes.
No, your reference
No.
angle can never be negative.
There we go, it's just the absolute value of it, good. Less than 90,
How did you know that?
because it said it in the thing earlier.
Oh, I thought he was totally guessing on that.
I did 100%
He did.
guess on mine.
You should have went with it, Sheen.
I'm not even.
Hit enter.
I'm not about that.
Alright. Okay, so you should be able to do practice problems from page 280 and 281. Go ahead and hit stop, please. So 280